Welcome to Math TV with Professor V. In this video, we're going to learn how to solve word problems that involve quadratic equations. So this is video lecture number 43 from Intermediate Algebra. If you haven't watched the videos prior to this on the playlist that deal with how to solve quadratic equations, I recommend you do that before you dive on ahead. But here we're just going to start setting up word problems. The setup is definitely the hardest part for most students, so let's jump to it. First example. During the first part of a canoe trip, Tim covered 30 kilometers at a certain speed. He then traveled 12 kilometers at a speed 4 kilometers per hour slower. If the total time for the trip was 4 hours, what was the speed on each part of the trip? So anytime you have these motion problems, I like to call them, whether it's little Timmy canoeing or someone flying an airplane or rowing in a river, etc., you're going to use distance equals rate times time. And then let's set up a table. I think that's the best way to do it, to summarize all the information that we're given. And then after you set up the table, we can see, okay, how can I write an equation using all of this that I'm going to solve and answer the question with? So notice here, there's two parts of the trip. He has a first part of a trip, and then there's a second part of the trip where he's slowing down. Maybe his little arms got so tired, poor thing. So two parts to the trip. What does that mean? I'm going to have two rows in my table. So distance equals rate times time. Those are pretty much the columns, okay? And then we have part one of the trip, and we have part two. So those are our two rows. And then let's fill in the information that we have in the word problem, okay? So let's see. In the first part of the trip, he covered 30 kilometers. That's the distance for part one. So please put a 30 right here for the distance. At a certain speed. I don't know the speed. Okay, time to bust out a variable. I'm going to call that speed x. Don't get too fancy schmancy and try to use s or stuff like that. I think it just messes with your brain, okay? X. They didn't say anything about the time. Did they? No. So this is blank right now. He then, so now we're talking about part two, traveled 12 kilometers. So that's the distance for part two of the trip. Okay, watch this. At a speed 4 kilometers per hour slower. Slower than x. So make sure you get the order of subtraction right. 4 kilometers per hour slower is 4 less than x. That's going to be x minus 4, not the other way around. And just think about it. Think what makes sense in your head. Say he was going 10 kilometers per hour originally. What's 4 slower? It's 6. How did you get there? 10 minus 4, not the other way around, not 4 minus 10. When you're doing subtraction, the order is super important that you get it right. Otherwise, it will mess up the entire problem. Okay. Do they say anything about the time on part two? No, they don't. But what do they tell us? They tell us the total time for the trip was 4 hours. That's the total time. Total time would be the time from part one plus the time for part two. That should be 4 hours. So here's the thing. Resist the urge to bust out a second variable. It's unnecessary, okay? If you're doing a quadratic equation, you got to stick to just one, especially if you're in algebra. So how am I going to fill in those entries for time on part one and part two? Watch this. If we know distance equals rate times time, and I'm missing time, isolate t in this equation. So distance divided by rate equals time. Do you agree? Oh, good. So that means the time for part one is going to be the distance covered in part one, 30, divided by the rate in part one, which was x. And then similarly for part two, the time for part two is going to be the distance, 12, divided by x minus 4. Good. Now, how do I write an equation using this table? That will be different for every single word problem. In this particular case, they told me that the total time for the trip was 4 hours. So that means the sum of the time for part 1 and part 2 should equal 4. So here's my equation. 30 over x plus 12 over x minus 4 equals 4, right? That's the sum of the time for part 1 and part 2 equaling 4. Now this is a rational equation, and we've studied these before. When we solve, we want to make sure first we list the domain, and then we're going to clear out all of the fractions. We don't want anything in the denominators by multiplying through by the LCD. So domain, remember, you don't want any zeros in the denominator. That means from this guy, x cannot be 0. And also here, x cannot be 4. Okay, so those are our 2 restrictions. Now we have to multiply the equation through by the least common denominator, least common multiple, same thing in this case. It's going to be x times x minus 4. The goal is to be fraction free. Okay, so I'm going to multiply everybody by x and x minus 4. Okay, and if you need to actually write it out and distribute, go for it. I'm not going to because it's just going to make it messy. So I'm going to do it mentally. If I have 30 divided by x times x and x minus 4, this x will cancel out with the x in the denominator. So all I'm going to be left with is 30 times x minus 4 plus 12. Now notice in this case, when this distributes to 12 over x minus 4, the x minus 4 will cancel. So I just have 12 times x left. And then nothing cancels on the right. So you've got 4x times x minus 4. All right, looks good. Let's distribute. I mean, it's looking better. There's no fractions. We should be excited. So this is 30x minus 120 plus 12x equals 4x squared minus 16x. As soon as I notice, oh, I got a quadratic equation, quadratic because there's that x squared term, let's set it equal to 0. And then we'll decide from there, can we factor or do we need the quadratic formula? Okay, so setting everything to 0. Before that, let's clean up. This is 42x minus 120 equals 4x squared minus 16x. So I'm going to subtract 42x. and add 120. That way I have a 0 on one side. It doesn't have to be the right side, okay? Whichever side is nicer. I want a 0 on the left because I like to keep the x squared term positive always, okay? So now we have 0 equals 4x squared minus 58x, oops, plus 120. Now before I try to factor or do the quadratic formula, I notice I can divide everything by 2. So let's go ahead and do that, okay? Okay, Professor V, good. So we have 0 equals 2x squared minus 29x plus 60. Okay, good. So it's up to us. Let's see if this factors, and if it's giving us too much of a headache, we can do the quadratic formula. I've shown in a video before how you can do splitting the middle term with the AC method. So you put a times c up top. So a is 2 and c is 60. So a times c is 120, and then b goes in the bottom, which is negative 29. So can you think of two numbers that multiply to 120 but add to negative 29? And it's negative 24 and negative 5, right? Negative 24 times negative 5 is 120, and they add to negative 29. So what I'm going to do is now split the middle term. So I have 2x squared minus 24x minus 5x plus 60 equals 0. Let's take out the greatest common factor here. That's 2x. And then we have x minus 12. Here I can take out minus 5. And then we have x minus 12 is 0. And then, ooh, look at x minus 12, x minus 12. I can factor that out. And then you have 2x minus 5 equals 0. Okay, now from here, I need more space. It is what it is. Okay, so from here, let me copy all of this. And let's go down here. We'll return momentarily. From here, you're going to use the zero product property, set each factor equal to 0, and then solve for x. So x is either 12 or x is 5/2. Now, both of them won't work. So in a word problem, you have to think like what's going to make sense. X is the speed on the first part of the trip, okay? And then x minus 4 is the speed on the second part of the trip. So if x is 12, that would mean he's going 12 kilometers per hour on part 1. And then 4 less than that would be 8 kilometers per hour, which makes sense. If x is 5/2, that's 2.5, right, as a decimal? So if he's going 2.5 kilometers per hour on the first part of the trip, he can't go 4 kilometers per hour slower than that. It would be negative. So I can tell, oh, this one doesn't make sense. I'm throwing this one away. Okay, so here's the answer to the problem. This gives us the speed on each part of the trip. Okay, but I know what you're thinking. You're thinking, oh my goodness, Professor V. It was kind of aggressive to factor 2x squared minus 29x plus 60 equals 0. Like, how did you come up with, negative 24 and negative 5 to split the negative 29? Yes, I am a factoring queen. I know. I've done this for a long time. If you're still struggling and that's just too tricky of a way to solve it, then you can use the quadratic formula, okay? So it's nice, let's review, because it's helpful for situations where the factoring might be a little hard. Let's write out the quadratic formula. X equals opposite of b plus or minus square root b squared minus 4ac all over 2a. And then here's a, b, and c, right? A is 2, b is negative 29, and c is 60. Okay, the only thing is with these big numbers, the computation is going to get a little tricky. So make sure, you keep your skills sharp. I don't know if your instructor lets you have a calculator or not. So opposite of b is going to be positive 29 plus or minus square root b squared. That's negative 29 squared minus 4 times 2 times 60 all over 2 times 2. So this is 29 plus or minus square root 841, that's negative 29 squared. The negative goes away. Minus 4 times 2 is 8 times 60, 480. Over 2 times 2 is 4. And then this is going to be 29 plus or minus square root of 361 over 4. Which is 29 plus or minus 19 over 4. So how do you proceed from here? Will you do 29 plus 19 over 4 or 29 minus 19 over 4? You got to separate them at this point. 29 plus 19 over 4, that is 48 over 4, which is 12. Or 29 minus 19, that's 10 over 4. Which is 5/2. And dun, 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 those are the same answers we got when we factored. And then we knew to throw away this one, and we kept 12 kilometers per hour. Okay, the question did ask though, what was the speed on each part of the trip? So make sure when you answer the question, you say 12 kilometers per hour for part 1, and then 12 minus 4, which was 8 kilometers per hour for part 2. Okay, good. All right, let's look at the next example. This is a work problem. We've done some before in previous video lectures, so the setup's going to be the same. It's just this time it's going to be a quadratic equation to solve. So 2 pipes are connected to the same tank. Working together, they can fill the tank in 2 hours. The larger pipe working alone can fill the tank in 3 hours less time than the smaller one. Woo! Okay. How long would the smaller one take working alone to fill the tank? So I know, these are so gnarly when you read them. They sound terrible, but they're actually not that bad once you see the pattern to them. Always let your variable represent the quantity that you have the least information about. What do I mean when I say that? Okay, so they're telling me right here, this is the sentence. The larger pipe working alone can fill the tank in 3 hours less than the smaller one. So they're telling me all this stuff about the larger pipe. They didn't tell me anything about the smaller one. And then the question says, how long would the smaller one take working alone to fill the tank? So that's what I'm going to let my variable be. So I'm going to let x be the time it takes for the smaller pipe to fill the tank, okay? And then if the larger pipe takes 3 hours less time, then that means x minus 3 would be the time for the larger pipe to fill the tank. Do you see how that works? Okay. So let your variable represent the quantity that you have the least information about. Okay, so in 1 hour, let's see what equation we can write. You always do it in 1 unit of time, okay? So if the smaller pipe takes x hours, after 1 hour goes by, it has filled up 1 over x of the tank. What do I mean by that? Okay, think about it. Pretend we had a number for this. Pretend it takes 5 hours for the small pipe to fill the tank. 5 hours. I'm just saying pretend. Just pretend. Okay. 5 hours. If only 1 hour goes by, what fraction of the job is done? 1/5 of it, right? Or say it takes 2 hours. After 1 hour, half of it is done. So 1 over the time is the fraction of the total job that is completed. Okay, so in 1 hour, 1 over x is filled from the small pipe, plus how much has the large pipe contributed? 1 over x minus 3. And it told me it takes 2 hours when they work together. So after 1 hour, how much is done? 1/2. It's always 1 over the time, 1 over the time, 1 over the time. Do you see that? Here's our equation. That's it. We didn't have to make a table. Do you hate it? Don't hate it. Just practice and you'll love it. Okay, let's list our domain. So x cannot be 0 or 3. And then now I'm going to multiply everybody by the LCD. Let me write it out here. The LCD is 2x times x minus 3. If you are struggling with that step, then you need to review solving rational equations. I'll link that video here. So you multiply by the LCD in the numerator like this. 2x, x minus 3, 2x, x minus 3. This is the step I didn't show earlier because it's a little cumbersome. Okay, look, and then here this x cancels. So then you just have 2 times x minus 3 plus, then the x minus 3 cancels, so this is 2x. Then the 2 cancels here, so it's x minus 3. Okay, so in the last problem, I didn't write this all out. You can do it in your head, no problem. Okay, let's clean up here. See, we're fraction free. So 2x minus 6 plus 2x is x squared minus 3x. So we have 4x minus 6 equals x squared minus 3x. We have a quadratic equation, do we not? Set this bad boy equal to 0. So 0 equals x squared minus 7x plus 6. Oh, this one's much cuter than the last equation. Heavens to Betsy, we can factor this, no big deal. 0 equals x minus 6, x minus 1. I love it. So x is either 6 or 1. One of these doesn't make sense and we got to throw it away. Which one? Yep, 1. Why does that one make no sense? Because if x is 1, 1 minus 3 would be negative 2. That wouldn't make sense for the time for the larger pipe to fill. Okay, so let's see. Can we answer the question? How long would the smaller one take working alone to fill the tank? Yes, the smaller one would take 6 hours by its lonesome. Okay, we answered the question. Do you feel victorious? No. It's only with lots of practice that you can do these effortlessly. It's like, I always say this, if I watch gymnastics, which I love watching gymnastics. I can watch it day and night, but it doesn't mean I'm going to be able to do anything impressive on the balance beam other than tumble off. It's only until you practice at something tirelessly that you too can do it effortlessly, okay? And it's algebra. It's not as bad as gymnastics. I know it might seem worse to some of you, but it's really not. It's not. All right, let's change gears a little. Let's still look at some different kinds of equations. We've previously solved formulas for specified variables. For example, say you have this rational equation and I ask you to solve for Q. What that means is you need to isolate Q, right? Whatever they ask you to solve for, you need to get that variable by itself. In this particular problem, since it's a rational equation, we would multiply by the LCD, which is PQR to everybody, okay? And then you would have QR plus PR equals PQ. Oh, this one's funky. What do you do when the variable you're solving for is in more than one place? Do you remember? You want all those terms on the same side of the equation. So I'm going to leave PR over here, and then let's get everybody who has a Q together. They want to be together. They want the Q's to hang out. Yes. And then we're going to factor it out. Okay. So PR equals Q times, P minus R. And then now just divide by P minus R, and you've got Q by itself. Do you see that? We've done this before. Being able to solve for a variable with this technique is very important. Oh my goodness, you're going to have to do it throughout your math career. You're going to have to do it in pre-calc when you find inverse functions. You're going to have to do it in Calc 1 when you apply implicit differentiation and you solve for y prime. So being able to recognize, I'm solving for Q. It's in more than one place. Put them together and factor it out. If you remember that, you're going places, okay? Anyways, now we're going to deal with quadratic equations or equations with square roots and solving for variables. So, same idea. Say you're given this equation. Don't worry about what it means, okay? Solve for L. Get L by itself. Well, I'm looking. L is there in the denominator under a square root of all places. L, what are you doing there? Get out. Okay. So let's square both sides. Then we can get rid of the square root at least. So W equals 1 over LC from the hills. W squared, excuse me. Okay. How do I get L out of the denominator? Let's multiply everybody by LC. Not Lauren Conrad. Okay. So we've got LCW squared equals 1. Who do I want by itself? L. So divide by everybody who's bothering him. C and W squared. Be gone. Okay. So that means L equals 1 over CW squared. And we're done. Okay. We're not going to get a number for our answer. We're just solving for or isolating a variable. Now, next one, solve for B. Ooh, a little different. B is inside these parentheses, and that quantity is being squared. So what undoes raising something to the second power? How do you undo that? You take the square root, right? But be careful because we have that square root property, which tells us when we take the square root of both sides of an equation, when we apply the square root, we have to put plus or minus. So then now I have a plus b over here. You don't need parentheses anymore. Equals plus or minus square root of c. And then I'm trying to get b by itself. So this time I'm going to subtract a. They're not being multiplied, so don't divide by a. Just subtract a. Subtract a. And then that looks a little ugly. So the way we usually write our final answer is we would have negative a plus or minus rad c. Kind of similar to how we have it when we use the quadratic formula, right? You want that plus or minus square root part at the end. Okay, I got one more problem for you. Look at us. You probably were scared to watch this video and now you're grateful. I hope. Now, you'll see this more in physics later should you take some physics classes, For falling objects, we use the formula S equals 4.9 t squared plus v naught times t. And I'm going to explain what all these variables are in just a hot second. So S is the distance fallen in meters. Yes, we use metric. T is time in seconds. That's kind of common sense. And then V naught is the initial velocity in meters per second. Okay, so that little zero subscript means initial, starting velocity. So let's do one little example. An object thrown downward from a cliff travels 91.2 meters in 4 seconds. What was the initial velocity of the object? So 91.2, that's the distance S. 4 seconds, that's t. And they want the initial velocity. So they want v naught. Okay. So let's substitute everything into the formula. S equals 4.9 t squared plus v naught times t. So S is 91.2. I don't put units in the equation. Your physics teacher may want you to though. Okay, but in math, I just don't like it. It looks messy. Equals 4.9 times 4 squared plus v naught times 4. So this is 91.2 equals 4.9 times 16, right? Perhaps I needed more parentheses like this, plus 4v naught. 4.9 times 16, that's 78.4. And then this is not even a quadratic equation anymore. I'm solving for v naught, which is not squared. So I'm just going to subtract 78.4. 91.2 minus 78.4, 12.8 equals 4v naught. Divide by 4. Divide by 4. V naught equals 3.2 meters per second. Don't forget the units, otherwise minus 1/2. So that concludes the video. Give it a thumbs up, click that like button. It would really help me out. Leave a comment down below. I love reading all your comments. How's your day going? I'm on summer break. So I just basically record, do ballet, do yoga, go to the beach, and then I'm helping my mom edit a book she wrote. What else am I doing? I am, doing some work here and there, but enjoying. I hope you're all enjoying too. I will make more algebra videos. They're fun. Why not? And catch me on Instagram and TikTok at MathTV with Professor V. I'll talk to you guys later. Bye.